All right, so today we are going to talk about descriptive statistics. And for that, I would like to show you that how to open some sample data in SPSS. First of all, remember whenever you install the SPSS software, a lot of sample data, they get installed as well. So they are in the installation folder. What you would do, you can either click on this icon, which is the open data document icon, or you can simply click on file menu and select the second option, and then from the drop down menu select data, which means that you're trying to select data from a particular folder. So if you go to the C drive where you most probably would have installed your softwares, and then you have to open the program files folder. Within that folder you will find IBM folder. uh, Within that you will have SPSS statistics, and since I'm using 26 version, I will click on 26 folder and look for the samples folder. Once you find it, click on English samples that are provided in English language. For this particular lecture, I will use two data sets. First of all, I'm going to open a data which is about diabetic patients. So I will just press D and it will take me to the databases that start with their name starts with D. So as you can see that there are a lot of databases. For example, if you open demo.scv, remember .scv is the file extension for SPSS. So if you open diabetes underscore cost.scv and demo.scv, diabetes underscore cost is not that much extensive uh, regarding variables, as you will see once I open this data set. Do open demo on your own and you will find a lot of variables in that data set. That is, I think, most probably one of the most extensive data uh, within the SPSS sample files. So I'm going to open this one, diabetes underscore costs. So I will select it and I will click on open and it will open the data for me. Now you can see that I have the data view in front of me and there are four variables. How can I know that? For every column, you have a title. So the title shows me that this is a particular variable for which different respondents have responded, or maybe data has been collected in a systematic manner from these many people. So if I press Control and downward arrow, I can go to the very bottom of the data set and I can look at how many rows are included in there. So 250 data values or data items have been included. That means 250 people have their data in this file. So I will click on Control and then pressing Control, I will click Home and I will reach to the very first row. And if you just hover the mouse over these names of different variables, you will see that you will find the name of the variable, their labels, and their type. So all of them are numeric type, either dollar or numeric. Now I will switch to the variable view just to see that what these variables are. Of course, there are some labels that explain that why this variable is there. For example, age represent the age in years for a respondent. Glucose actually shows the glycated hemoglobin level of that individual. Income shows the household income of that person, and the cost shows the treatment cost that they have incurred. And there are no particular ordinal or nominal values assigned to these variables, which means they all are scale variables. So they possess continuous numeric values. So these are all quantitative variables. And there was a particular reason for showing you this data set because there is no ordinal or nominal variable within this particular data set. If you're not sure what is nominal and ordinal data, you can watch the previous lecture or just Google it. You will find out the levels of measurement. They fall into four different levels. nominal, ordinal, interval, and ratio. So within SPSS, interval and ratio both are categorized as scale variables. Uh, Now I will try to run a couple of analysis on this. First of all, I will click on the analysis drop-down menu from the menu bar, and then the second option, which is about descriptive statistics, that is something which novice researchers at the beginning level they always try to calculate or run in SPSS. So I will click on descriptive statistics and then I will click on frequencies. And by frequency, we try to draw some kind of analysis from where we can know the number of times a particular item has shown up in the data. So for example, if I just click on age in here, so just carefully look at this dialog box, you will find this very helpful that in SPSS you have one window where you have all the available variables that can be used for that particular analysis. And then if you want to involve some variables in the analysis, what you have to do is just select the variable that you want to be included in the analysis and click on this arrow which is in the middle of these two windows, and that will bring the variable to the variables window. Now it shows me that now whatever analysis is being run in this uh, option, that will be run on these variables which are in the variables window. I can select multiple or all of the variables at the same time. I can move them back and forth. So you can try that on your own. But right now I am only interested in the age in years. Next, I have a lot of buttons here, but I will select the statistics first of all because there are a few things that I want to discuss here. They are really important to understand if you don't know statistics very well. That we try to represent data by some basic values. We try to sum up the data in some denominations or representations, like a few mayors that can explain what is going on within the data. For example, if I ask 250 people about their age and write 250 different values on a piece of paper, it would be a very difficult task to come up with an answer that what is an average age and which age is the most repetitive number. So a lot of question can rise, but it would be difficult to look at that page and answer those questions. So in order to summarize that data effectively, statisticians have come up with a few measures. First of all, the measure which shows where the concentration of the data is called central tendency. It shows that where is the center of the data, where the most of the data is concentrated. For example, mean shows you that what is the average in the data. Average means arithmetic average. You just simply add all the values and divide by the number of values, and that shows that what is the mean of the data. Next is median, and median in statisticians term, they call it the central value, the most central value. For example, if you make an array of the data, by array we mean that you sort it in ascending order or maybe descending order. The value which lies in the middle, exactly in the middle, is what we call median. Next is mode. Mode is the most repetitive value which has the highest frequency. For example, if most of people who are reported their age belong to 25, so 25-year age would have the most frequency in the data. And by some, of course, we mean the total aggregate of the values that we have in a particular category. So after looking at data from its central point of view, where the data is concentrated mostly, we see the spread of the data, the variation or dispersion of the data. So the next set of values that we are interested in are dispersion. And by standard deviation, we mean that how how the values are falling around the mean of the data. There's a center of the data and how data values are varying across the center value. So that is standard deviation. And then we have variance. Variance is the average dispersion within the data set. And then you can find out the minimum value in the data set and the maximum value. And the difference between those two is the range. And finally, you can see here SE mean, which is the standard error mean, standard error of the mean, which actually shows you a value of a sample data set in relation to the population, that how much sample error exists. So we are not going to go into detail of the standard error. There is a particular probability theory involved in it, which you can study on your own. And next, once we have understood the data from its central point of view and the dispersion of the data, then we are mostly interested in the shape of the data. That is it normally distributed or not? So let me give you an example here. For example, if you there was a statistician, I think by the name of Frederick something, Frederick Gauss. So he actually uh, measured the height of French women. So he measured the height of thousands of women. At the end of the time, when he finished his research, he came to know that the distribution of the height of women is normally distributed, which means the average height relates to most of the women. Most of the women have average height. So the center of the data has more frequency. There are very few women who are very short, and there are very few women who are very tall. So the tails or the ends of the data, they are very narrow, and from the middle of the data you will find a lot of frequency. So that is called normal distribution. But sometimes our variables can show a different shape. Okay, they will not fall exactly on the normal distribution. In that case, they will have skewness and kurtosis. Skewness means that they are towards the right or towards the left of the normal distribution, and kurtosis means that the frequencies are jumbled up in a particular value, which means there is a big hike in the middle of the data set. So that belongs to the uh, kurtosis. And finally, we also are interested in the measures of position, which include quartiles, percentiles, deciles, quantiles. And by those, we mean that we divide the data set into some equal parts. When we talk about quartiles, we divide the data into four equal parts. So if you have ever attempted uh, a test of NTS, you must have done that. You will find out they not only give you the marks that you have acquired in the test, but also the percentile. And by percentile, we mean that how many people, how many percentage of people were below your score. If you have 95th percentile, that means that 95% of people performed poorly than you. Okay, so that is percentile. Percentile is in percent form, which means the data is divided into 100 equal units. But quartile shows that data is divided into four equal units. So you have your first quartile at 25th percentile, the second quartile at 50th percentile, the third quartile at 75th percentile, and you have your fourth quartile as at the 100th percentile. Then we can actually give the software some particular cut points that you can divide the data at 10 equal, sets, or you can divide the data into five equal sets. So whatever number you like, or you can calculate the exact percentiles. So for this age value, what I would like to know is I will calculate almost all the values so we can see that what would be the outcome, how the result would look like. So I can add some percentiles here as well. So I will add the 85th percentile and 95th percentile. So just to show you that how these things work. So I will click on continue, next, okay. So within seconds, the data will be calculated. So now I have the statistics in front of me. And since I have calculated frequencies, it will show me the number of observations. There are 250 valid observations in the dataset. There are zero missing values, which means none of the respondents were, missing any data. All of the people had the observations included in the dataset. And the mean age is 44 years. The standard error of the mean is 0.754. Not going to go into detail of that. Median. So the exact center of the age data is 45 years. And the most number of people have an age of 51. So the mode is 51. Then you have standard deviation. So if your mean is 44, there is there is a variation in your mean of around 12 years. That means within your data set, there are people who are at least 12 years younger than 44 and 12 years older than 54. And then you have 142.2 variance. Variance is a kind of square of your standard deviation. Okay, so that is a statistical calculation that we have to perform in order to reach the standard deviation. So not going to go into detail of that. Now, the data is a little bit negatively skewed, and zero point 0.3 or 0.4 approximately is not a big skewness value. So skewness ranges from 0 to 1. It can be negative, it can be positive. When it is closer to 0, there is little skewness in the data, and when it is near to 1, there is more skewness. It is when it is 1, it is absolutely skewed and it is exiting from the normal distribution. And then you have kurtosis. So there is a negative kurtosis, which means the data is a little flat. Okay, the data does not have enough height to be counted as normal distribution. But again, 0 to 1 is the range and it can be interpreted accordingly. And the range of the data is 52, which means the minimum value is 13. There is somebody in our data set who is just 13 years old, and there is somebody who is 65 years old, and the difference between the two ages is 52. So the sum is also given of all the values of age, and then 25th percentile, 50th, 75th percentile. These three are the quartiles. Since I selected the option of calculating quartiles, the program has given me the quartiles, but there were two extra percentiles that I wanted to know, 85 and 95, and it is also given. All these are the ages in years. So you can see that within seconds, it has calculated a lot of useful information for me. So depending upon the nature of analysis, the nature of variables, these numbers can be very valuable for me. So I will move forward, and this is the frequency table. And by frequency table, we mean that there are a lot of categories or classes in the data. Since it is the data related to age, you can see the classes are represented by two-digit numbers. So first is 13, which means 13 years old people, 14 years old people, 15, and so on. So there is no one who is 16-year-old in our data set. Then you have frequency, that how many people fall into this class, into this category. So before 20 year, all the people, the classes that we have only have one frequency, which means only one person belong to this class. But there are three people who are 20 years old, there are five people who are 22 years old, four people who are 23 years, and so on. And as you can see, the highest frequency is associated with 51. There are 14 people who are 51-year old, right? So that has the highest frequency and the highest percentage in the data. Now you can see the next column is percent, that what is the proportion of a particular class in the overall data set, and then valid percentage. The difference between percent and valid percent is that valid percent calculates the observations with missing values adjusted into it. Let me give you an example. For example, you have 250 people participating in this study. So the percent is calculated using 250, but assume there are 10 values missing. So the denominator for valid percent will not be 250. It will be 240 because 10 values are missing. Finally, cumulative percentage is the additive percentage, that how many people fall below a particular level of this scale. For example, if I want to know that how many people in this data set are less than 30 years old, I can simply look at the cumulative percentage. So 16% people are below the age of 30. Okay, so this is just a generic frequency table. There are a lot of things that you can do with frequency tables. You can modify them, you can have some bins in them, you can use these to create histograms and so on. So we'll look into those things also. But I want to show you one more thing. This data set does not include any ordinal or nominal variables, but usually when we collect data from a managerial perspective, some of the variables are usually ordinal or nominal. And, and there is a relationship between the point which I'm communicating now and the options that I have in the program. For example, let me go back to Analyze menu, Descriptive Statistics. Now I will click on Descriptives, and you will see a similar kind of window. So if I click on Options, you will see some similar kind of options also here. Mean is there, standard deviation, variance is there. Now your question would be that why two different menus, two different dialog boxes with almost similar kind of notation, similar kind of analysis. Let me even go further, and within analysis value menu, descriptive statistics, and click on explore, and then click on statistics. Again, descriptives, and these descriptives, for example, if I run these descriptives for age, let me see if it can do. Usually you need an ordinal, variable. So you will see that median and various standard deviation, minimum, almost the same kind of, values. Why different dialog boxes, different menu options, but they have similar kind of analysis? Why is that? There is a reason behind that. And let me explore that reason for you. So first of all, I will click on open icon. I will click and another, let's open another. Um, let's open bank loan data. Okay, use this file for working. So when I click on bank loan data, you can see there are relatively more number of variables, and more number of variables also include some ordinal variables. As you can see, there is this ordinal sign with ED, which is most probably the level of education. I can see from the label. And then you have this nominal data, which is only categorical data. And this is nominal Meyer, numeric data. And you can see that this is about previously default, which means there is somebody who has defaulted on their loan or not. So I have all of this data. I can go to the variable window and I can see that how this data has been entered into the software. And the ordinal and nominal data would usually have something included in the values. So let me click on this and you will find that one is assigned to a particular category, two to another category, three to another category, and so on. Now let's perform a couple of analysis to see that what is the difference between different options in the descriptives menu. So I will go to the analyze descriptive statistics and now I will click on explore. Here I want to explore the household income of different people. So I will move that variable to my dependent list. But I want to analyze the household income according to the age of people, or maybe the level of education. Let's talk about level of education because level of education is ordinal variable and it can be really useful for this analysis. So I will drag that particular variable into the factors list, that I want to know about household income, but according to a particular factor, which is the level of education. I will click on statistics and just try to know that descriptives is selected. So I will click on continue. And now when I click on OK, The analysis will be run and the output window will appear shortly. So here is the output window. Now see, first of all, it tells me what is the case processing summary. And within this case processing summary, you will find out that I have 460 total people in one category, 225 in 35 in the other category, and so on. And there are no missing values. So the percentage and the valid percentage both are same. Next, the descriptives. Now, the descriptives are not given to me generically. They are divided into different levels of education. For example, the household income for people who did not complete high school is given separately from the household income for people who completed high school degree, right? And so on. Again, things that you would observe are most probably similar. The mean is given, the median, the variance, standard deviation, minimum, maximum, and range is given. The interquartile range is the difference between 75th and 25th percentile. The interquartile range shows you where the 50% central data lies. So the 50% central data is covered within the interquartile range. I will talk more about this. So you can see that I'm not given a single mean. I am given the mean for every respective category of the factor that I gave the software. So now I can analyze the data through cross tabulation. Next, the software has provided me a couple of graphs. So first of all, it has provided me the stem and leaf plot. The stem and leaf plot shows you that there is a stem. For example, when I was calculating values, I was actually gathering information from my respondents. The values they provided me had a stem, which is the first digit, and then there was a leaf, which is the second digit. So this is the household income, and it can be in the form of thousands, it can be in the form of millions. But when we talk about household income, there is one house which has the income level of 30. So one is stamp and three is leaf. Then there are around six houses that have 14 level of income, and so on. The highest number of houses fall in this category, which is the category of 20s. So mostly houses they are in the 20s and specifically within 21 to 25 because 25 is included in the next category. So 21 to 24, 20 to 24 is the category here. So this time and leaf plot is also a pictorial representation of the data, but it distribute different values into different categories, so you can easily understand where most of the values lie. And since that was the data about income, now I have also another stem and leaf plot, which is about the degree of that particular person, right? Let's move forward and let me go towards the end of it where I have a box plot. So look at this box plot. On the y-axis, you find there is household income, and on the x-axis, you have different categories. There are people who did not complete high school, people who completed high school. There were people who went to some college education, people who had college degrees, and then finally people who had post undergraduate degrees. Now, there are box plots in front of you, and you have to understand that what this box plot means. So there are two whiskers of every box plot. By whiskers, I mean these lines extending from the box. There is a lower whisker and there is an upper whisker. And then there are blue boxes in the center of these two whiskers. These blue boxes, they represent the interquartile range. And by interquartile range, we mean the central 50% of data. So if I talk about in quartile sense, the lower boundary of the box is what we call 25th percentile or the first quartile. 25th percentile means that 25% data falls below the start of the box. Then you have a solid black line, horizontal line in the middle of the box that represents the median or the 50th percentile. This is in the exact center of the data. Okay, so this is your median or the 50th percentile. Then the next 25%, which means the 75th percentile, ends on the upper end of the box. And the remaining 25% is above and beyond the box, right? So you can see that there are some boxes that are not too tall, and there are some boxes that are taller than other boxes. And the last one is pretty tall as compared to other boxes. Why is that? That totally depends upon the spread of the data, because the last box has more spread in it, more variance in it. But you will also find that some of these boxes have these kind of circles and stars in, below them or above them. There is no star below them. Given that there were some stars below these boxes, they would be called the lower outliers. And the stars and the box and stars and the circles that are given above the boxes, they are called the upper outliers. What are outliers? They are the data values that are extremely deviated from your normal distribution of the data. They are not part of the normal data set. Of course, they are part of the overall data set, but they are excluded from the normality. That's why we call them outliers. So these are the data values that can distort our analysis. For example, if I look at this particular category where people belong to those, groups where people never went to the school, you will find somebody who is earning more than 300,000, and that person in my data lies on the line 751. So the case number 751 in my data is a person who is who never went to the school but still actually earns more than $300,000. Okay, so this can be a point of study for me. This can be a case study for me. Maybe this has happened because of an error, or maybe I need to go into depth and know more about this case. Similarly, there are other outliers that can be represented by the software by these circles and stars. Okay, so if I look at the last one, there are no outliers, which mean all the data is a part of the normal distribution. So how we calculate these outliers? There is statistical base for that. There is a formula for that. You actually calculate the interquartile range, which is given to you, and then multiply that interquartile range with 1.5, and then you deduct it from the first quartile and add it to the last quartile. Not going to go into detail of that. You don't need that. The software is doing everything for you. So I think that should be sufficient for you. So now let's calculate a few frequencies for another, you know, variable. For example, if I go to analysis and I click descriptive statistics, and now I will click on frequencies, but this time I will use my ordinal and nominal variables for this analysis. I will click on statistics. I will click on mean, median, mode, standard deviation, variance, and quartiles. I will click on continue, and let's see how it turns out. So the analysis values are given here. You can look at them, but look at this. The frequency table is a lot different from the frequency table of age. So most probably the frequency tables are most relevant with ordinal and nominal variables. For continuous variables, you can have histograms, you can have different types of charts, but not the frequency tables, because they can be very lengthy at times. Here you have a few categories. For every category, you have been given a percentage, then a valid percentage, a cumulative percentage. Hence, you can um, incorporate the meaning into these numbers. For example, there are 27.6% people who have a high school degree. In the data set, there are only 5.8% people who have a college degree, and only less than 1% people who have a postgraduate degree. So most probably this data was collected from an area where there were not many educated people, or not people who were enrolled in higher education. And then people who previously defaulted, they have two categories. Either they have defaulted or not defaulted. So there are 73.9% people who have not defaulted, and there are 26.1% who have defaulted. Now you can see there's a difference between percent and valid percent. And the reason for that is because we have missing values. The data is not available for 150 people. So there are 150 entries missing from the data. And because of these missing values, the percentage is underestimated, under calculated. The actual percentage is, you know, in this valid percentage column. Now denominator will change for this valid percentage calculation. We will exclude 150 from 850 to calculate these valid percentage. Okay. And cumulative percentage is also calculated based upon the valid percentage. So once you are done with this, next thing I want to talk about is in the analyze menu, crosstabs. So crosstabs are almost similar to what we call the explore options, but they have a few things that make them different. So let me put the level of education in rows, and the household income in the columns. So when you have data that you want to represent in a matrix form means that you have rows and columns. You can do this. And then from the options, if I click on cells, I can uh, click on percentages, row and columns, which means when you represent the data in front of me, represent it not in the actual numbers, but in percentage form. So I will click on continue. I will click on OK, and I will have this amazing table. Look at this table. The table actually has two variables in it. There is household income, which is divided into different levels. So there are so many levels as we saw in the frequency table, but now these frequencies are divided according to the level of education. So you have the actual count, then you have the percentage. Okay, so that percentage actually shows you that how many percentage of people fall into this category, who are also people who never went to the school, did not complete high school, right? So then you also have people who have these, other levels of education, and then the corresponding level of income. So that is cross tabulation. One more thing, let's talk about the analyze, and let me go to the correlate menu, and I will select by variant. And now when we talk about correlation, we cannot use nominal variables for correlation analysis, which means correlation means how variables correlate to each other, how much percentage of correlation exists between variables. So I will select a few variables here. Let me select 4 variables. I will click on options. There is nothing to change, only exclude cases pairwise should be selected. Click on continuous and leave the check mark on Pearson, because there are 3 different correlation coefficients. And since this is not a statistics course, I'm not going to go into detail, but Pearson's correlation coefficient is the mostly used correlation coefficient, and the two-tailed test should be used for this. Let's click on OK, and you will find out this correlation matrix. So every variable, when it is calculated on correlation coefficient with its own self, it will give you 100% correlation, which is equal to 1. But if there is one variable like years with current employer, and this variable has a correlation with the current address, and the correlation value is 0.345. That means there is 34.5% correlation between these two variables. And these two stars show that these numbers, this particular coefficient has been flagged. By flagged means that this correlation is significant, statistically significant. And other way of looking at statistical significant correlations is that there is these numbers which are called p-value or the significance value. If this is less than 0.05 or 0.01 in this particular case, then they are significantly correlated variables. So at the bottom of the table, you can see that these stars are given explanation. So this is the correlation matrix, which is usually used in research to produce correlation tables. Next, I want to show you a couple of graphs. Let's see. For example, if I click on the graph menu and then select chart builder, this message will appear. I usually select don't show this dialog again. I click on OK. Now this particular dialog box opens in front of me, which shows me a lot of graphs. We have some bar graphs, line graphs, area graphs, pie graphs, scatter plots, histograms, okay, and so on. So I will select a histogram. And in this histogram, I have to drag the kind of histogram that I want to make from this, some thumbnails that are given to me. I will drag the thumbnail into this particular working area. Now it tells me that this is a simple histogram. There is x-axis, there is y-axis, and then there is filter. So remember, histograms are mostly relevant to continuous data, quantitative data. Okay, so for example, I want to put the household income on x-axis, right? And I want to filter this histogram according to the level of education. So I will put the filter over here. Now the histogram that you're seeing in front of you is just a sample. This does not show that this would be the pattern of your histogram. Histogram can be different. And then you have different options here that you can sort the values according to the values or labels, or the direction of those values can be ascending or descending. Then you can have the different order of these options here, right? You can change the order of the options and how the chart would appear, how you're going to color the categories, and so on. So I will let you explore that on your own. I will simply click on OK, and I will see that how this histogram will look like. So look at this. This is a histogram where household income is shown, and the frequency for that household income is also shown. Now, if you look at this histogram, the level of education is not apparent here. It says that it is filtered by the level of education, but it is not that much apparent here. So I have to play with it. So I have to change a couple of things in it, and that can help me to recreate it in the format that I would like to see. So I can also access all the options from the output window as well. For example, if you look this, there is same menu bar here. So I'm not going to go to my data window. I will simply click here on the graphs and then chart builder, and the same window will appear in front of me. Now see, what I will do is I will just play around with the variables in here. For example, I will put the household income on the y-axis and the level of education on the x-axis. And I will see this template is going to change, and this will show me that somehow it is going to appear in the kind of category that I want. So when I click on OK, I will see another graph appearing in front of me. And this is the graph that I kind of wanted. Why? Because you can see now there is exactly different categories that I wanted to show and their level of income. So people who have more education, they are earning more, as it is appearing from the graph. But you can see that if you have some college education and if you have a college degree, it is not going to make much difference for these people. So this is not for everybody. You cannot generalize these things, but for the data that you have on hand, can give you some, measures for that. Okay, so one more thing is that if you double click on this graph, it will open up the chart editor. And within this chart editor, you can do a lot of things. You can change the color of different, uh, bars and their fill color, their border color, right? You can change according to your, whatever options you want to apply. You can do that, right? It's a pinkish kind of color. I don't like that, but anyway, you can change it to whatever color you want. And also you can change the size of the graph, and you can also have other bar options that the bars can be a little narrow, right? Or bars can be wider, and there can be some depth, and never use shadows in the graphs. They are very misleading because you cannot have the exact measurement in the graph. So the outlines and shadows, they need to be removed. So I would remove them, both the shadows as well as the border. So let's put it at minimum, so distraction is least. Okay, so you can also change variables and their access, but I want these to be in the same position, because we saw that how variables on different axes can change the meaning of the graph. Right, so this is just a simple bar graph. This is no more a histogram, because in histogram the lines are adjacent to each other. This is a histogram because there is no gap between the bars. But since we wanted it to be in a categorical form, it has appeared into a bar graph. And there are so many other, graphs that you can explore. For example, let me make a scatter plot. Scatter plot is usually the plot between two variables. And now, instead of level of education, let me delete level of education. I will put here some continuous variable. For example, let's see that other debt in thousands. So we have the household income and we have the debt in thousands. So we will just click on OK. So we will see that how these two variables are turning out. So there were 250 people in our data. So there are almost 250 dots on this graph. And this graph is showing a pattern. Like if you have, if you have a sense of these graphs, you can see there is an upward sloping trend in it, but it is not that much strong. It is concentrated to a particular point. So people who have like an income of less than 100,000, they usually have a debt of less than 10,000. So more income means more debt. There's a bit of relationship with that, but not exactly linear and not so spread it across a particular linear pattern. It is aggregated in a particular area. So that is another graph you can study. Now, before we move any further, what I would like you is to just open a few sample files from the sample data sets, then explore this descriptive statistics manual, and then explore the charts and graphs from chart builder. So do study these, do practice, and do some kind of fun activities with these, and you will learn from just doing it, from the hands-on experience. Of course there will be mistakes. You will try to learn that how you actually wanted to produce something else, but it has given you a very different answer, and that would be a point of learning for you. From there you can start to actually accumulate knowledge about SPSS. So next time I will talk about different kind of inferential statistics tests and how they can be run into the software. Let's talk about that in the next session. Thank you very much.